بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Welcome all for the first lecture in our course selected topics, computer science. Lecture number 1, Introduction to Machine Learning. Let us to start by review quotes. The first one for Bill Gates, the chairman of Microsoft. A breakthrough in machine learning would be worse than Microsoft. What does this mean? This means that machine learning in the future will be the big thing, because this comparison between technologies, Microsoft technologies, and with machine learning will be very huge. The second one for machine learning is the next internet, the Tony Teaser for research and development defense for the United States. This is meaning that machine learning will be in the next internet. Will be the new important things in the world, around the world. Will change the lifestyle of the world. The new third one, machine learning, is the hot new things. So this is okay. Okay, this is also the hot new thing. This is for the president of university, Stanford University. Web rankings today are mostly amateur machine learning. Also, this is for Yahoo. Machine learning is going to result in a real revolution, meaning that we have real revolution for machine learning. This is based on the impact of machine learning in different domain or different discipline. Machine learning is today's discontinuity, meaning that machine learning is for discontinuity. This meaning that the gap of technology will be huge for different. Huge revolution will be in technology will be very important things. Also, the internet and our based on different technology, machine learning are distinct technologies. But the comparison is made to emphasize will be here for discontinuity, meaning that is the gap, their gap for new technologies, or the gap in the technologies. Technologies discontinuity refer to a significant and a change in technology that fundamentally alert the way things are done. Also, the impact on industries and data-driven decision-making or automation and efficiency for machine learning algorithms. This is the challenges or a consideration for this discontinuity meaning. Topics to be covered in this lecture. What is learning? We'll define what is the learning. Introduction to machine learning versus traditional programming, why machine learning, how machine learning works, what is the responsibilities and role of machine learning, how machine learning will be gross or gross for different disciplines, relevant disciplines, also applications of machine learning, some issues in machine learning, types of machine learning, and machine learning process. So let us to start for what is learning. Learning is a verb. Learning is a verb. Also, the activity of obtaining obtaining a knowledge. The activity of obtaining a knowledge. This meaning that you learn. What is the meaning of knowledge obtained by study? So if we define a learn, meaning that define is the activity of obtaining a knowledge that obtained by a study or using a study. So what is the learning in human and what is the learning in computer? So learning in a human is يعني traditional learning, meaning that to start from lifestyle with start from maybe to see or to think or to cognitive or for example this is can يعني discriminate between the water and the fire and so sense the cold, sense the temperature, the hot and so on. This is the learning for human. Learning in computers, meaning that we have different things. Actually, this is different from the human. So what is the how can you use this يعني different parameters to يعني start for learning in computers? Actually, nature will be different. How? This is based on adaptability, speed, context awareness, also explainability and creativity is different. So human can sense, human can cognate, human can interact, human can respond. But for computers, computer meaning is that through machine learning, so using or can rely on يعني set of algorithms and data to analyze pattern hacking. This is for example for adaptability and contextual for how understanding using in computers. While humans learn quickly and generalize knowledge or getting knowledge, generalize knowledge, but computer process data rapidly performing repetitive task consistency. So human also learn benefits from transparency and the ability to articulate reasoning, while some computer models, notably deep learning networks and so on, challenges in interpretability and so on. Humans also excellent in creativity, drawing, intuition, and imagination. But computer so capable of generating creative output. Also for this is based on the predefined set of rules, the predefined set of rules. So also can use different parameters, different devices for vision, for computer vision, for camera using, for mic, and can using anything for auto drive, for sensing, and so on for a based on discipline or automation. So what is learning definitions? We have set of definitions of learning to acquire knowledge, the acquisition of knowledge or skills through study, experience, or being taught. This is by Google. Also learning, making useful changes in our minds. Marvin Minsky. A program is set to learn. Marvin Minsky is a scientist in artificial intelligence. Computer program is set to learn from experience, E, with respect to some class of tasks, T. and the performance measure B. So we have experience. Experience meaning that data set. So we have experience. We apply algorithm, and then we uh, gain or acquire output of prediction. So, but need to measure and again to enter again input again to so for enhancement for optimization and so on. This is by performance measure. So why need to measure? Need to measure because this measurement is very important to the system able to optimize the problem, optimize in the algorithm, and then can get different output or improved output. The action of receiving instructions or acquiring knowledge also for a machine for learning, a process which lead modification of behavior of the acquisition of new abilities or response, and which is additional to natural development by growth or maturation level. Example for soccer learning a problem for playing soccer. This is task for performance measure. We can measure the percent of games on against opponents. We have a training experience. This is based on set of rules and set of يعني, concept playing set of practice games against itself. So based on these sets of practice or these data sets can apply algorithm, apply task, number one here, apply task, and then using the performance measure to again to measure the percent of out. Also, we can use a handwriting recognition learning problem. This is to recognize words, to recognize words or classify handwritten words within image. This is task, and we can measure based on the correctly classified, based on how many words correctly classified from each image. So this can give us the percentage. Also, training meaning is that the training is this is the database or dataset handwritten words with given classification. So you have many handwritten words using. So another example for robot driving learning problems. This is robot driving or auto driving. This is can using by task to drive on a public for land highway using vision sensor and can measure meaning that to judge by using by human overseer. Training experience here, we can use the dataset or a sequence of images and the steering commands recorded while observing a human driver. So we can take care for this structure is very important for every task. So task T, performance measure is B, and the training experience. So I said that before, you have to have skills to يعني, define your problem accurate by updating the task. What is the task? What is the performance measure? And what is the training experience? So these examples of learning to recognize spoken words, also learning to drive an autonomous vehicle, learning to classify new astronomical structure, learning to play world class Pac-Man, learning to play chess game. A learning system, in order to complete design of the learning system, we must now choose the exact type of knowledge to be learned. Number one, the exact type knowledge. Number two, representation of this target knowledge. Number three, the learning or learning mechanism will be used. So number one, to type of knowledge, the presentation of target knowledge, and then what is the mechanism using for learning. The game, checkers game for play soccer. This is task for B, meaning that is the performance percent of games. This is for performance. So we have task and then this performance. So what experience here? That experience should be data set. What is the experience already defined? Also, what exactly should be learned? You have to define what exact should be learned using this experience. So how shall it be represented? How can you represent it using images, using roles, set of or sequence, and so on? What is specific algorithm to learn it? This is a big issue to define the specific algorithm to learn this task. So this is the generic system, generic learning system for given input variables and using the hidden variables to obtain the output variables. So we have input is given x1 to n here as input, and then using h variables or parameters that can use for applying system itself for using from h to hk to will deliver or gain or obtain the output variables y. This is generic without any specification for any problem. Just this is abstraction for generic learning system. So let's start for introduction to machine learning. Machine learning definitions. Machine learning is a subset of artificial intelligence, AI, that focuses on the development of algorithms and models that enable computers to learn from data and make predictions or decisions without being explicitly programmed. Meaning that what is the meaning of without being explicitly programmed? So to predict, you have to, meaning that we have a model. So this is a model already using the algorithm or delivered from the process of a training process. So, or model means that the pre-trained model or pre-trained model meaning that that model is the programs. So the meaning that this is the programs. The programs meaning that enable computer to learn from data and make a prediction or decision without being explicit program. No need to make a change explicitly in the code to change or to improve. This is the primary goal of machine learning is to allow computers to automatically learn and improve from experience. What is the meaning of experience here? Is the data set. The data set. So experience meaning that data set. Again, machine learning is a subset of artificial intelligence, AI, that focus on development of algorithms and models that enable these models, enables computer to learn from data and make predictions or decisions without being explicitly programmed. So as machine learning is what machine learning is automating automation. I mean that automating automation. So automation itself already to systemize any problems in domain, but we need to automate this problem itself. So this is a automate automation, meaning that automation, the program itself. So deliver the program, deliver model that used for decision or prediction and so on. So getting computer to program themselves. So this meaning is that a programs themselves is programs is output or writing software is a bottleneck is very difficult. So bottleneck for to write software to enhance or to using for each time. But for machine learning, no need to write software again for, but let's data to learn or to talk or to speak for to predict to get us the output. So let the data to do the work instead. Let the data to do the work instead. Actually, this data set will talk. This example for gardening, this is for how distribute for algorithm, what is the algorithm, or this is the task for seeds. Suppose we have seeds is the task, nutrients for as the data or experience to make a plants growing. So the plants cannot grow without nutrients. So a gardener, this is you to prepare all these things. So what is the deliver? What is the output? Here from the machine learning problem, the machine learning process, we have plans. So this is the program. This is the model already delivered. So machine learning versus a traditional programming. What is the difference between themselves? So machine learning or decision or prediction, given given data and representations or feature selection, this will deliver or predict information by applying the process here on each one here. So the input is data. The data may be textual using a natural language processing or visual for camera, or audio, sound, or speech for video, and so on. So this representation using can represent based on histogram or represent using back of words. These examples of representation. Feature selection and dimensionality reduction. So feature selection, how choose features, how this is based on a set of algorithms can use to rank features and then choose these features or to make a feature reduction or dimensionality reduction. This to improve. Why using this? To improve the process. And so machine learning equal decision or prediction. So this is will deliver or out the predicted information already will get. What is machine learning? Predictive data analytics is the art of building and using models that make predictions based on pattern extracted from historical data. So the problem here, we have historical data and then using algorithm to build models, and then we can use it to predict the data, to predict the information on what we need. What is machine learning? Machine learning, again, branch of artificial intelligence. The same already definition already talked about before in the previous slides. For construction, the study the systems that can learn from data. Learn from data. So machine learning is the programming computer to optimize. Machine learning programming computers to optimize the performance. Criterion using example data or past experience. Machine learning is defined as an automated process that extracts patterns from data. So we have set of data or data set using will apply this data set will apply algorithms. So will based on the pure data set, this is we can extract from these features and applying the process or algorithm to predict the information, required information. A traditional program is everybody know we have data and or inputs using roles. And roles just can using these roles and can build semantically these roles, and then based on this implementation using our algorithm, so we can deliver the output of calculations, for example, and so on. So each role is based on logical foundations for each one. Also, this is grows complex, more roles need to be written. It can quickly become unsustainable to maintain. Why? Because this is implemented once. So we cannot develop. Develop meaning is that you have to open the code again and then implement a new code. So you have to develop inside the implementation of that. But for machine learning, already we deliver the model. So this model, the code already implemented. But you can use or any data with to predict or different output, different input, you can apply it to predict this one. So also actually you can add more than data set for to enhance or to improve this accuracy of the model. So this is the machine learning. A goal of the machine learning is to build computer systems that can adapt and learn from their experience. This is Tom Dietrich. The machine learns how the input and output data are correlated, and it writes a rule. The programmers don't need to write new rules each time. So if we back here for traditional, meaning that the programmer have to solve bugs here by updating these rules to enhance the problems and to calculate the output without any bugs. But here, no need for adding more rules or just already update the algorithm. The algorithm already formula or the algorithm already statistics, probability methods already applied based on the data, and this will deliver the rules. So rules here meaning that will be delivered. So we have here the program, we have here the program, or we can say model. This model meaning that already dynamical set of rules will apply based on different or data values can use. So this data as input can using it, a model will deliver output or can use to predict the information in machine learning model. So why output here again? Because we learn from output. So this is we'll learn it from supervised learning, for example. So suppose we have this data as this is supervised data, and then this is the target of data for target or a label column. So this will deliver the rules or our model for machine learning. Again, the programmer don't need to write new rules each time. There is a new data. The algorithm adapt in response to new data and experience to improve efficacy over time. So this is the difference between traditional and machine learning. Here, given data and program will deliver output, but for machine learning, given data and output, so will deliver the program. Why machine learning? Machine learning is programming computers to optimize the performance criteria using example data or past experience. So there is no need to learn to calculate payroll, for example. This is not a financial system. This is not a HR system. This is not application traditional system. So learning is used when human expertise doesn't exist. So this is for a navigation example on Mars. So navigation of Mars, we cannot, there is no expertise. It doesn't exist on Mars. Humans are unable to explain their expertise for speech recognition. So there is no expertise can explain for speech to recognize this is can be speech and so on. So machine here come in this area to solve these problems based on this cannot using the traditional application. Solution changes in time, routing one on a computer network, for example. This is another one for routing. Solution needs to be adapted to particular cases, use biometric, user, medical, vital, science taking, and so on. So all these problems can use the machine learning. So why machine learning? We cannot program everything. We cannot program everything. Some tasks are difficult to define algorithmically. So this is to be taken in mind. This is should be considered, especially in computer vision. Computer vision cannot for using for surveillance camera. So surveillance camera can using this is cannot manual. Also, this is need to yani difficult. It's very difficult to define this thing. So machine learning come in this case, and sometimes look similar is not semantically similar. So you can look similar is not semantically similar. So we'll define learning problems, easy to learn versus difficult to learn, varying complexity of visual patterns, and so on. How machine learning works? Machine learning works. The goal of machine learning is to develop methods that can automatically detect patterns. The goal of machine learning is to develop methods that can automatically detect patterns in data and then to use the uncovered pattern to predict future data or other outcomes of interest. So machine learning is about predicting the future based on the past. So machine learning meaning is that learn from the past to predict in future. So learn to create model or predictor, and then using this model here to this model here come here, and then using for testing data using different data because here the past training data or experience already provide to learn, meaning that for a training process and then generate the model or pre-trained model. Here, pre-trained model will be used for to predict. The way the machine learns is similar to the human being. The way the machine learns is similar to the human being. Humans learn from experience. Machine learning also learn from experience, but experience here means that data set. So the more human learn from experience, the more we know, the more easy we can predict. Easily we can predict, meaning is that accurately we can predict. So human also, if human learn more experience, so also machine learning more experience can gain. To make an accurate predictions, the machine sees an example to the core objective of machine learning is the learning and inference for or test or validate uh, uh, the data set. Learning phase. First of all, the machine learns through the discovery of patterns in the data. We need to choose carefully which data to provide to machine. The list of attributes used to solve a problem is called feature vector. So this is feature vector already or data set. The list of attributes, this is the list of attributes used to solve a problem is called feature vector or feature vector. This is a feature list. We can use this as the feature list already defined as in the data set. So we have to define this is the contour or this is the star or whatever. This is set of feature list for highlight for this is pixels, contour, and so on. I think you are familiar using image processing course. So this feature vector defined or extracted from data sets or from image, for example. Suppose we have a data set is the image data set, and then we extract the feature list or feature vectors. Then using this feature vector as the input to algorithm or to machine learning algorithm for prediction. For example, this is as, for example, to this decision tree or different machine learning method. And then using this will deliver the model. So this model can using to using for inference. Inference meaning that this for test data and so on. So this is the same. If you look to again for this is the learning phase. Learning phase, we talk it training phase. Training phase also. Training phase meaning that we use algorithm, use data set, and with feature this to train. Maybe this data set is supervised data set or unsupervised. So the process will be called supervised learning. Supervised meaning that everything is there for a feature and then the target for each label for each record. So suppose this will deliver the model. After that, took this for inference phase. When the model is built, we need to test it on never seen before data, new data. The new data are transformed into feature vector. Also, suppose we have this the new image or did so will feature extract the feature list here or feature vector. So using our model, pre-trained model from previous phase and then for to predict the new image. Maybe this is for in domain different model. So there is no need to update the rules. No need to update the rules in this model. This model already built or generated from the previous phase, which is learning phase. And then now in the phase, second phase for inference phase, means that using this model to predict the new data. So there is no need to update the rules or trained against the model. So you can use the model previously trained to make inference on the new data. This is actually related to our inference phase. So based on the revision of or review machine learning algorithm learns the relation between set of descriptive features and target feature based on a set of historical example. Very interested definitions. We can then use this model to make prediction for new data instance or record. So suppose we have a training data set. So this machine applying machine learning. So this descriptive features, meaning that the feature list with target feature. So this is a label or target, our target. Using this data set for training to generate the model, a prediction model. So use this model here for prediction process given the query instance or new data, new data, a new different data. This is the prediction for new data. So we can use this model to make prediction for a new data. So this activity for data set of mortgage for that a bank has granted in the past. The dataset includes descriptive features and a target features. Descriptive features tell us three pieces of information: occupation, professional, or industrial. So suppose that we have this feature, occupation, and we have age, we have loan sale ratio. So based on this feature, we have also the target feature. So this is three feature is the descriptive features. So ID cannot consider ID, but the occupation, age, and loan sales ratio. Also, this is the target or outcome. This is the target features. Based on this data set, we need to generate the machine learning model and then use this machine learning model for inference or predict the new data set. So data set is the descriptive feature, as we mentioned before, ratio between the applicant salary and then amount of the loan taken. So this is based on outcome. Target feature is set either default or rebate. So the value of rebate or default based on these values. So a very simple prediction model for this domain would be if loan sale ratio greater than 3, then outcome equal default, else outcome equal rebate. So suppose that we check, for example, manual, for example, loan sale ratio greater than 3. If it greater than 3, meaning that example, this is, so this is the, will be default. Why? Because this is greater than 3, so outcome will be equal default. So this will lead to as a default. And then we use only this feature for this rule to add it here. Else outcome will be repay. So if less than 4, meaning that will be repay. If less than 3, sorry, if less than 3, so this will be default, will be rebate, sorry. So 2.9, meaning that less than, so will be rebate. This is greater than 3, greater than 3, greater than 3, greater than 3. So all these default. This is less than 3, meaning that will be rebate, 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 and so on. So this is greater than. So this is, so what is the feature that can use for to define the outcome? This is loan sale ratio. The model is consistent with the dataset as there is no instance for which the model failed. When new mortgage application come, we can use this model to predict whether the applicant will repay or will be default and make a decision based on this prediction. So there is no use, no, as this is misuse for age or occupation. So machine learning outcomes process a model that captures the relation between descriptive features and target features. So this is a relation between descriptive features and target feature in a data set. Or for simple data set, we may be able to manually create a prediction model. And in an example of this scale, machine learning has little to offer us. But in case data size is large, then we need situation will be different. So take care for this case or situation. So this in case we have activity number 3. The same data set, but different activity. Activity number 3, a more complex data set for the same problems, but with more descriptive features. The earlier activity number 2, prediction model, is no longer consistent with this data set. We need to build another one. Like, for example, we can using this also for roles greater than 3 only, and this can define outcome, repeat, or default. But because we have different here occupations, property, type, and so on. So we need to add more rules. So if loan sale rating less than 1.5, then outcome will be repay. Else if greater than 4, then outcome will be default. Else if age less than 4 and occupation equal industrial, then outcome will be default. Else outcome will be repeat. So to manually learn this model by examining data is almost impossible. We cannot use as we tried before in activity number 2, as we tried here. This is very easy or simple to apply single rule as possible here. This is possible here because this is the model is consistent with the data set. But here we use this is different, mainly different. So the model is not consistent with this data set. So we have to add more rules. This is will be difficult or impossible to using manual. So for machine learning algorithm, this is simple because this is well just يعني to extract these features, this descriptive features here, this is descriptive features, and then using algorithms such decision tree for prepare for each attribute or feature here vector, and then we can until reach decompose until reach to the leaf, so can use make a classification. So to build the prediction model for large dataset with multiple features, machine learning is the solution. So machine learning is the solution now for using with the large dataset. So this is the large dataset, so we can use the machine learning model. So machine learning to study algorithms that to improve their performance at some task with experience. So optimization performance criteria using example data or past experience. Role of statistics or inference from samples. This is for testing. Role of computer science efficient algorithm to solve optimization problems to representing and evaluating the model for inference. So gross machine learning, we talk gross machine learning. Machine learning is the preferred approach to speech recognition, natural language processing, computer vision, medical outcomes analysis, for example, robot control, computational biology, text mining. So text mining here, يعني some basics, يعني we have overlap for machine learning, the preferred approach to here for natural language processing. Also, this is can using in text mining. So text mining meaning that use machine natural language processing, but for speech recognition that can using this is for also computer vision using computer vision for camera, for videos, and so on to use the image processing. So medical outcomes analysis. So medical maybe image, also maybe clinical data, and so on for using to analyze this problem. So machine learning is will use for this time. Robot robot control also for using to automation or for drive for auto drive for using for speech, using for natural language processing, using with computer vision, using with sensing, and also for different things in machine learning. Computational biology. So computational biology can using a high accuracy in different problems using in medical or biology for competition in environment. We can in environment or in text or in the plants, for example, any plans for environment plan for environments for sustainability systems for related to environment, also for different biology. Also for text mining, so text mining is a very large scale of problems here can using is for how can understand the text. So understand text meaning is that you can translate, you can summarize, you can generate, you can asking answer and question, you can using clustering documents, you can using classification a problem for uh, different types, and so on for text to mining meaning that here for understand text, understand meaning that can as target all these problems. So also for this relevant disciplines, this figure يعني يعني explain different things or different problems using different machine learning or artificial intelligence in general. So basically, we have artificial intelligence as this big circle for AI, and in an inner circle for machine learning. This is for machine learning, and the inner, more specific, deep learning method. So meaning that deep learning is machine learning, and deep learning is artificial intelligence. So take care for this concept or terminology. So all deep learning methods is actually is machine learning methods and in the same AI artificial intelligence. So this is for يعني overlap with big data. Big data overlap in all areas, all circles here for take some algorithms related to artificial intelligence, which not machine learning, and machine learning algorithms or systems, which is not deep learning, using also a deep learning model, which is machine learning or artificial intelligence. So also for here for cognitive and learn dynamically for artificial intelligence in general, natural language processing with robot and knowledge base. This is the concept for types of artificial intelligence concept. Artificial intelligence can use machine learning process using for artificial intelligence, can use deep learning with natural language processing, can use deep learning with knowledge base, can use deep learning with robot. So take care for that here, this position, not meaning that it cannot use using deep learning. But here for big data Perspective meaning that the best outcomes. For predictive, just what could happen. This is for in the future. So, but here for descriptive meaning that what has happened in past. So this for descriptive meaning that for what has happened, but for predictive that what could happen for in the future perspective. So perspective meaning that best outcomes uh, in in the big data. So I think this is a figure, or this figure has set of definition for each things in big data. For example, prospective analytics or predictive analytics or descriptive analytics. This is very important for what is the example of each one. For prospective example, can say that recommend or can we, for example, for pricing strategies to maximize profit, so suggest resource allocation to maximize efficiency and advising inventory and so on. For predictive analysis, so this predictive meaning that a future, so this predicting customer churn or forecasting sales and estimating equipment failure and so on. But for descriptive, this meaning that descriptive involve analysis historical data to understand what has happened in the past. So problem for anything, any problem happens, so we need to analyze. So this descriptive, so example for generating reports, creating dashboard, and visualizing data to understand historical performance metrics. So applications of machine learning for speech and handwriting recognition, telephone menu navigation, uh, uh, telephone menu navigation based on a sequence of steps to choose numbers or whatever. Computer vision, mail sorting, so also is very important. Biosurveillance for computer vision, also identifying diseases outbreak for pandemic and so on for identifying diseases, robot control, autonomous driving, data mining, bioinformatics, and playing games, fault detection, clinical diagnosis, spam email detection, also retail for marketing, basket analysis, customer for relation management, also finance for credit scoring, fraud detection, manufacturing optimization, troubleshooting, medicine, medical diagnosis, telecommunications, quality of service optimization, web mining for search engines used. This set of application in machine learning. So some issues in machine learning, what algorithm can approximate functions will and when? How does number of training example influence accuracy? So take care for these issues can be consider for each one should be considered. You can, as a brackets, you can use each one, search about for each issue and how solve this issue. Actually, to talk about, you can ask yourself, you can search about what algorithm can approximate functions will and when. So you have set different problems. So you have different problems, but how choose the appropriate, how choose the suitable, how can approximate functions will, and when can use this algorithm. So this is very easy or very important because to this is maybe use the how to choose the right algorithm and how to choose the right algorithm. How does number of training samples influence accuracy? This is very important also by trial or what is the the criteria influence for accuracy and so on. How does complexity of hypothesis representation impact it? also for complexity of hypothesis presentation. Also, this is very important. How does noisy data influence accuracy? How does noisy data influence accuracy? What are theoretical limits of learnability? What are theoretical limits of learnability? Theoretical limits here for to يعني what is theoretical limits use or already can be in machine learning for of learnability to improve to speed the process training. How can prior knowledge of learner help? So this is historical data for prior knowledge. What clues can we get from biological learning systems? So we can use it for as a data for biological learning system. How can system alter their own representations? So also all these issues can be a question need to answer, but this is as you can search about it and then we can talk in the future. Types of machine learning. How many types we have in machine learning? We have different types for what we can يعني defined as four types. Supervised learning. Um, this is supervised learning, meaning that inferential task driven. And the second one, unsupervised. So the first one, supervised, and second one, unsupervised. The third for semi-supervised learning, and the last one or the fourth is reinforcement learning. So reinforcement learning. The first one, supervised or inversional task driven. This can be maybe regression as a continuous or classifications. This is sharp identified or for unsupervised can be one of the supervised problems is clustering, dimensionality reduction, feature reduction, anomaly detection can be also used for unsupervised. Unsupervised means that we don't have any target feature, but we have descriptive feature only. So, but here we have descriptive features and with target features. So this for training, and then we use inference for to predict different data as to use prediction. Supervise, already we have data, we have target, and then we can already apply it on regression problem or classification problem. But if the dataset aren't supervised, meaning that we don't have the target, we don't have the label, so this will be descriptive. So the problem is used here for this clustering. So just we can group it clustering or يعني we can draw dendrogram, for example. This is as the hierarchy for each one. Some this is with the cluster, only one cluster, but this is will become another one, and we can use and so on. So we can use this is three in the same, and this is come here. For example, this is use this with one, and so on. So uh, uh, this is the sample number 1, 2, 3, 4, 5, 6, 5, 7, and so on. So this is, we call this dendrogram or agglomerative algorithms. But we applied dimensionality reduction here to optimize and to enhance in features. Also anomaly detection, one of the problem using with unsupervised. Semi-supervised learning meaning that we have set of data set already. We have target, but not complete target. We have target, but we have losing in the target feature. So we use some algorithm to filling the missing here to become a supervised link. So this is semi-supervised link, but we cannot agree. We cannot guarantee that accuracy for this model 100%. So this is for co-training and active learning. Reinforcement learning means that we learn from mistakes as algorithm learn to react to environment. This is for using Markov decision process. So this supervised and unsupervised with continuous or categorical based on as we have a regression problem or a classification problem for supervised. So for supervised regression, meaning that is continuous classification. Continuous regression meaning that the output will be 1, 2, 3, or 100, for example, 20, 200, 300, or 3000, for example. This is number for this is regression, meaning that the number. But the classification, true, false. For example, class number one, yes, no, for example, or maybe can use we have multi-classification if we have 1, 2, 3 also. So class number one, class number two, class number three. We can use until reach, for example, multi-classification. We can use this for for 1 to 100, for example. So 100 classes already there. But not in between. We can say in 1.5. This is not, if it's 1.5, meaning that series continuous, this is will be regression target. So what are the types of machine learning? This figure explain main task performs in each type of machine learning. So this task performs in each type of machine learning. This is we can, for example, the classifications problem and regression problems also using by supervised learning. Also reinforcement problem. We have here for unsupervised learning with dimensionality reduction or clustering. If we look to a classification, you can use fraud detection for this task. Also problem image classification using also customer retention and diagnostics. For regression, we can forecasting. We can forecasting for temperature, for weather forecasting, for everything. So this is the regression because this will be continuous. Prediction, some prediction regarding to the regression using supervised learning. A process optimization, a new insight. This is for reinforcement actually using for to improve or optimize from error or from mistakes for robot navigation, skill acquisition, learning task, game, AI, or real-time decisions, and so on. So this clustering, also customer segmentations, targeted marketing, recommended systems for clustering. For dimensionality reduction, we can use with big data visualization, meaningful compressions, structure discovery, feature elicitation. So this is types of machine learning, main task performance in each type machine learning. Types of machine learning also supervised. This is what is the methods or algorithms for each one. Predictive model label data classification. We can use, for example, logistic regression, decision tree, KNN, a random forest, support vector machine naive bias. Numeric prediction, linear regression, also KNN gradient. So we can use more than in the same for classification and the numeric prediction. So we can use the same based on this supervised, based on this classification problem, and so on. For unsupervised, meaning that we use key means. Key means meaning that clustering. So clustering or key means as a key means algorithm using with the clustering descriptive model unlabeled data. Unlabeled data meaning that is there is no target, but here labeled data using or delivered the predictive model, but here using descriptive model. Descriptive for the clustering or and so on, feature reduction. As semi-supervised learning, mixture of label and unlabeled. Reinforcement learning using this algorithm, the machine is trained to make a specific decision. The machine is exposed to an environment where it trains itself continually using a trial and error. This machine learns from past experience and try to capture the best possible knowledge to make accurate decision. Example of reinforcement learning, Markov decision process. Markov decision process. So supervised learning is the first type of machine learning in which label data used to obtain algorithm. The algorithms are trained using market data where the input and the output are known. The input set of data is called feature, denoted by X. So we have feature along with corresponding outputs, target class label indicate by Y. So we have this is for as the algorithm by comparing its actual production with correct outputs to find error. The raw data divided into two parts, training and set. So we divide the raw data into 70% for training data set and 30% for testing data set. So just to use the first section here for to train. So suppose this data set already 70% of the data set using to as a supervised, this is duck, this is duck, the same image for duck, the same image for duck, but this is not duck, it's rabbits, huh? Right? So also this is not duck, this is different. So we have class duck or not duck. This is the target of our model. So even this is duck, yes or no. So this is well prediction using the supervised learning. So just we trained 70% of data set for our model using this image. Maybe this is a class, right? True, false, false, and then we can measure the accuracy and then generate the model. So if we generate model here, we can use the 30% of validation, and then this is for to measure what is the percent of accuracy, and then using for test by using this one image for test example, this is a duck or not, this is duck, so this is success, and so on. So this is features or images can extract to feature feature extracts the feature list of the duck and then using for so a training process. So classification or regression, what is the difference? The classification build the predictive models from training data with which have features and the class label. This is the classification. This classification use the feature learned from training data and new previously unseen data to predict and so on. Output class are discrete 1, 0, and so on. A type classification algorithm include decision tree, random forest, support vector machine, and so on. Type. Regression, meaning that is continuous, also will use not discrete, also use a predicted output value based on the same input feature obtained from the data. So algorithm build model with feature and output values of the training data, and this model is used to predict values for new data. Output values in this case are continuous and not discrete. So using this algorithm for regression, for logistic regression, multivariate regression, regression tree, and also regression among many other system. For clustering for unsupervised learning, so we can use this is the goal here is to divide the input dataset into logical group. So this is the target for logical group related items. So this is meaning that similar new articles, for example, this is a grouping. So if we need to if we need to classify this bubble, for example, in the same shape or this points, so we have to measure the same figure, the same, but how? So, for example, this is you can use this uh, as a clustering. We have two clustering and so on. This is cluster number one, cluster number two, and so on. So this is the grouping for similar and so on. This is the clustering for. There is no label here for this is what is this circle types or what is features for this and then what is called this called for example open circle and this is for closed circle and so on. So dimension reduction here the goal is to simplify a large input dataset by mapping them to lower dimensional space. For example, carrying analysis on a large dimension data set is very computational intensive. So simplify, you may want to find the key variables that hold a significant percent, say 95% of information, and only use them for analysis. Anomaly detection, or is also commonly known as outlier detection, and to is the identification of items even. All this for dimension reduction or anomaly detection for to remove extreme or expected pattern. So this is actually using for pre-processing for any models, but actually these techniques يعني correlated to or related to unsupervised learning. So this is a descriptive model. Also, machine learning system has monitoring, event detection, fraud detection, intrusion detection, and so on. Semi-supervised learning, meaning that machine learning is the combination of supervised and unsupervised machine learning method. In semi-supervised learning, an algorithm learns from dataset that include both labeled and unlabeled data, usually most unlabeled data. Why is semi-supervised machine learning is important? Why semi-supervised machine learning is important? When you don't have enough labeled data, what you will apply? How? So you have missing for fraud detection, for example, this value already missed. So we can use semi-supervised learning algorithm to label the data. So to filling this data as label the data model with the newly labeled this new hair, this is 0 and this is 1. How can get this? There is no way, take care, there is no way to verify that the algorithm produce labels that are 100% accurate. No guarantee. No guarantee for that, resulting in less trustworthy outcomes than a traditional supervised technique. So this will use this, but take care for this is not accurate 100% because the, we use semi-supervised to complete the missing or missing values in target. But it's very important to use for the missing data. Reinforcement learning for observation gathered from interaction with the environment to take action that would maximize the reward or minimize the risk. So this reinforcement learning based on observation. So the called agents also for we called it agents that continuously learn from environment in an iterative fashion. In the process, the agent the agent learns from its experience of the environment until it explores the full range of possible state, meaning that it will be well trained. In order to produce intelligence program, also called agents, reinforcement learning goes there the following steps. Number one, input state is observed by the agent. Number one, to a input state is observed by the agent. Decision-making function is used to make the agents perform an action. After the action is performed, the agent receives reward or reinforcement from the environment. So this in reinforcement built based on reinforcement function. So this is error on the observation or in the implementation. So the state action, bear information about the reward is stored. So store this state action and so on. Repeat this process till يعني fully possible state يعني range of possible learn. Some applications of the reinforcement learning algorithm are computer played board, for example, played board games or chess, go robotic and self-driving cars is very يعني examples in reinforcement. For example, a program to play a game or drive a car will have to constantly interact with dynamic environment in which it is expected to perform certain goal. So this is a reinforcement learning. So now for machine learning process, machine learning process, collecting data, preparing data, training data, evaluating the model, training a model, evaluating the model, improving the performance. So this scenario or the approach or the process of machine learning or machine learning framework. So the step number one to collect the data, if you try to يعني start in the project or research or whatever you want to, you يعني ask about the data set. So the data set is the key of or the soul of the model. So we cannot train our model without collecting data, without a data set. So data set should be having a variety, density, and volume of relevant data will help in the better learning. So if you have the same data set without or your data set is not have or variety or density, so this is maybe يعني weak the results of your experiment. So preparing data that involves fixing issues with the data set collected. Example, handling outliers, reprocessing. يعني you try to clean your data. You try to visualize the data before to see outlier, to see the noise in data. For example, maybe this is voice or speech. So this is need or maybe image. It's not clear. Maybe it's image too. You have to visualize. You have to evaluate. You have to handle the outliers. You have to remove the noise. You have to clean your data set. So this is the preparing data. A training model meaning that try to after the data here clear, after the data clear, try to train, choose appropriate algorithm and representation of data in form of the model suited. So for each algorithm given the input of each algorithm is should be in form. So you have to prepare your data based on this form and to apply the training model using the algorithm and then use the training data set to train the model. So evaluating the model to test the accuracy and precision of the model, use the test data set kept aside in step number 2. طيب, improving after evaluating the model, we have model and we satisfy by the accuracy and precision for this model. So try to improving the performance. It may involve choosing different model and algorithm or together or introducing more variable. Or maybe use you can use also a collection of algorithms, and you can use different algorithm. You can use optimization for this algorithm for model. You can change in parameter, hyperparameter. You can change in different values of the parameter hidden, and then to optimize, to improve the performance of your model. So the same workflow machine explore data, visualize feature selection, feature extraction, and then using based on the type of machine learning. So use evaluation for precision, recall, or overfitting. Take care for maybe you have low data set or view data set that can cause overfitting based on the testing occurs. So this model will generate, but to be focused on the problems in your experiments based on. Take care for the accuracy. Take care how to measure what is the evaluation factor should be measured. Metrics should be measure accuracy or measure the errors or and so on for a based on your algorithm. So this is the machine learning, also a flow chart or a framework for machine learning. The same, suppose you have a training set for this data, maybe supervised or unsupervised. So this is a feature extraction from this data set based on your data, maybe an image, so maybe speech, maybe text. So this will extract the feature, and then this feature extraction, one of the pre-processing step, and then use for to apply feature reduction and enhance your features, and then using the algorithm for implement or apply training. Suppose you prepare implement or applying a training, so you can deliver the model. So your model based on unsupervised learning or supervised learning. If unsupervised learning here, so this meaning that will generate the grouping objects or clustering, whatever this descriptive model. So, but for predictive model, for based on supervised model, this is will generate the predictive model or classification, for example. And you can use this model for annotate data again, and you can enhance the model based on by itself. Thanks very much for listening this lecture, and see you inshallah in lecture number 2 in machine learning. Assalamu alaikum wa rahmatullahi wa barakatuh.